So let's continue our exploration of basic data shaping, and what we're going to do now is we're going to take a look at another type of our object, which is a data frame. So this is probably one of your most important data objects and object types in R. In fact, a lot of the analysis that's being done is done within the context of a data frame. So a data frame is essentially a spreadsheet. It's a tabular arrangement of rows and columns of vectors and or factors. And what you basically can think of is that the columns in a data frame represent data attributes, while the rows represent some kind of a record with values for the attributes. The only limit is that a data frame must have the identical set of dimensions, so you can have one column with 10 rows in it, another column with 12 rows in it. They have to exactly match. To create a data frame, you use the function data.frame, which requires different vectors as input. And like I said, the only restriction is that the vectors have to be of exactly the same length. And the input vectors that you pass in become your columns in your data frame. So here's an example of that. So let's say we have three vectors, var1, var2, var3. First one is a set of cities as characters. The next one is a set of numbers, and then the next is a factor with the levels above, normal, and below. And you want to create the data frame snow.frame. Again, remember that the dot in R is not really a property type, it's just part of a variable name. So here we use data.frame with var1, var2, and var3 as the input vectors. That creates a data frame called snow.frame. If we were to display the data frame, we're going to get var1, var2, var3 as the three columns, with then the different values in each of those vectors becoming the rows in a data frame. So you can really think of this as a spreadsheet arrangement. By the way, if you list the mode of a data frame, it's listed as a list, but the class, of course, is data frame. To access the columns in a data frame, you can do that using the dollar operator. So for example, you can use frame, dollar, and then the column name. So for instance, in this case right here, snow.frame dollar var1 lists you column var1. By the way, if you do a mode on that, that's a numeric mode because it actually converts them to different values. If you look at, for example, snow frame 2, again, it's numeric. There is an alternative to accessing data frames, and that is you can also, instead of using snow.frame var1, you can also use snow.frame and then bracket bracket, and then in quotes var1. That's actually an associative access. It actually kind of searches, if you will, for that. We'll see more about the associative access a little bit later on. And finally, you could also say snow.frame bracket comma 1, and that lists you all of column 1. If you, by the way, said 2 comma 1, it would list you row 2 column 1. So that's actually the way that you access the or specify the different cells in a data frame. It's row first, then the column. Next object we need to take a look at is the matrix. A matrix is often used in numerical calculations and mechanical engineering, other types of mathematics. It's a little bit less commonly used for typical data storage, but might come in very handy. Now, a matrix is like a data frame, two-dimensional, but unlike a data frame, its elements must be of the same data type. So you can't mix and match. You can't have characters and factors and numbers all listed in, like you can have in a data frame. In a matrix, they have to all be exactly the same. And if you want to perform any kind of mathematical operations on the matrices, the elements must be numeric, which is really the most common type of object you would store in a matrix. So to create a matrix, you use the matrix function. So in this particular case right here, we create a matrix of 3 rows and 3 columns. And we're going to use the function rnorm to create 3 normally distributed random numbers with an initial seed of 9. So Actually, sorry, this creates this creates 9 random numbers, and we're going to arrange them in the rows 3 and 3. So if you print out the matrix, you're going to have the 9 different numbers displayed like this. By the way, notice the mode of the matrix is numeric because it's a set of numbers, but the class of the matrix is, of course, matrix. You can also take a data frame, assuming that it has the same data types, the same object types with as.matrix. If it doesn't, as usual, R coerces the different data types into the same common data type. So numbers would become numbers and logical values would all become characters. So in this particular case right here, since we put an as.matrix on snow.frame, everything gets converted to characters. So if you look at the mode right here, it's exactly what you would expect. It's character. And of course, again, the class is still remaining as matrix. Now you can perform a typical mathematical matrix operations. For example, you can transpose a matrix where the rows and the columns get interchanged. So right here, we've got an original matrix. Just go take a look at this. And all you do here is, let's say, with the transpose, you transpose the corresponding rows and columns. All right, so that basically inverts the matrix, or not inverts the matrix, sorry, transposes the matrix. R supports a lot of the typical matrix manipulation functions like matrix multiplication. You multiply matrix with this operator right here. It's percent asterisk percent. So this is an example where we transpose the matrix M first and then multiply that transpose with the matrix itself to give us a new matrix. There are several other matrix operators available, but that's a little bit outside our need. Like I said, matrices are great for things like machine learning, predictive modeling, various engineering applications, and so on. I wanted to mention matrix because it is an important data type, although for most of the work that we're going to do, data frames are actually one of the more appropriate data structures. But even though data frames are probably the most commonly used data structure for us, I still need to discuss with you two other important data structures, arrays and lists. So arrays are, again, multidimensional data structures, while matrices and data frames are restricted to 2 dimensions. So for matrices and data frames, you can have rows and columns, but for an array, you can have rows, columns, and so on. You can actually, go further. You can have, a third dimension, a fourth dimension, and so on. So this can be very helpful if you have multi-dimensional storage need where you might want to store values behind some row and column. So here's an example of that. So we create an array A right here. Using the array function. And we dimension it to 2, 2, 3. So we're then going to assign to the first dimension 2 randomly distributed normally distributed random numbers. Same along dimension 2 and same along dimension 3. Now we can print out the various dimensions of the array by just simply printing it out with A. And that gives us 1, 1. This is 1, this is 1, 1, 1. This is 1, 1, 2. This one, for example, right here would be 2, 2, 2. And this one right here would be 1, 2, 1. So 1, 2, 3 is 1, 2, 3. So that's how you actually get to the different elements in the array. You can also access the array elements through subscripting, like A1, 1, 1 gets you to, that appropriate element, and so on. Finally, last data type we need to take a look at is the list. The list is a very interesting data type in that list is essentially a bag data structure. So you can put into a list anything you want. You can put vectors, arrays, matrices, data frames, and all sort of put together into a list. So a list is really more of a sort of a data structure for carrying large things around. So for example, right here, if you have the object L, it's a list of a vector, an array, a matrix, and a data frame. So if I were, for example, say list sub 2, I would get to the array, and then I can, of course, access the different elements in the array. So here's an example of that. So print it out, you get this. Now, interesting would be what would happen if you want to access a particular element. Well, let's see. I want to get to element 3, so it would be L sub 3. That's how you access the different elements, like this. And of course, the third element was a matrix, so that's what you end up with. You can also, by the way, do it like this, and you get the element as a matrix object versus a data object. So in this lesson, you learn that vectors are probably one of the most commonly used data structures. They are one-dimensional arrays, essentially. Data frames are two-dimensional with a row-column layout in which each column must be of the same data type and the column sizes must match. It's probably the most commonly used data type. Matrices are two-dimensional numeric data structures that can be operated upon. Arrays are multidimensional data structures where each element is of the same type. And finally, lists are similar to a back data structure where different elements do not have to be of the same type.